Good day, I am Jen Rose D. Benosa, taking a Bachelor in Elementary Education. In this video, I will discuss Module 1 about nature of mathematics. Or similarly, we say in nature or in the surroundings. So, first, I would like to look around and look these patterns or designs. So there are plenty right from the pattern of your window or tiles. All those patterns can be described by mathematics. So according to this one, recognizing patterns feels natural like our brain is hardwired to recognize them. Example, 10, 20, 30, 40, then blank. So the next term we can put 50. Why 50? Because 40 we add 10. So 40 plus 10 is equal to 50. So every numbers we add 10. So this is the pattern with numbers with which you add 10 by 20 so that you can get the next number. Let us proceed in patterns and numbers in nature in the world. So patterns are regular, repeated, or recurring forms or designs. Example, circle without color, circle with color, circle with color, circle without color. So the next circle with color. So this is the term. This is the pattern. Another example. What number comes next in 1, 3, 5, 7, 9, then blank. So the next term, we can put 11. So why 11? We add 2 by 9. So 9 plus 2 is equal to 11. So every number we can add 2 numbers. Let us proceed. The tiger stripe and henna spots. Patterns are also exhibited in the external appearance of animals. The semi-random designs are believed to be governed by mathematical equations. According to a theory by Alan Turing, chemical reactions and diffusion processes in cells determine these growth patterns. Another good example. So, packing problems involve finding the optimal method of filling up a given space, such as a cubic or spherical container. An example of packing problem is the structure and shape of honeycomb. So it is observed that such formation enables the bee colony to maximize their storage of honey using smallest amount of wax. Next, the Vitruvian Man or Leonardo da Vinci's Vitruvian Man shows the proportion and symmetry of the human body. So here we are other types of symmetry. There are other types of symmetry depending on number of sides or faces that are symmetrical. Rotational symmetry and the angle of rotation. Rotational symmetry is the property a shape has when it looks the same after some rotation by a partial turn. So, for example, ako mo rotate ko. So, same ra Japon ang akong position. So, the smallest that a figure can be rotate while still preserving the original formation is called. So, it's called angle of rotation. So, there are formula of angle of rotation. So, 360 degree over n. So, where n is the order of rotation. So, asa man ta magkuha ani og n. So, example, Flower, there are three petals. So there are three petals, so we can put the order of rotation. So 360 divided by n. So ang n na to is 3. So 360 divided by 3. So is equal to 120 degree. So or starfish. So starfish, there are 5 symmetry. So we can divide 360 divided by 5. So 360 divided by 5 is equal to 72 degree. So 120 degree and 72 degree are the angle of rotation. So next, this is the pattern of numbers. So when we say sequence is an order less of numbers called terms that may have repeated values. The arrangement of these terms is set by a definite rule. Example, analyze the given sequence for each rule and identify the next three terms. So, sample B, A. So, 2, 5, 9, 14, 20, then blank. So, paano na to makuha ang the next number? So, we add 3 numbers by 2. So, 2 plus 3 is equal to 5. So, moad na po taog 4 sa 5. So, 5 plus 4 is equal to 9. Moad na po taog 5 sa 9. So, 9 plus 5 is equal to 14. So, dayon, or next, 14, moad na po ta 6. So, 14 plus 6 is equal to 20. Then, the last, moad na po taog 7. So, 20 plus 7 is equal to 27. So, this is the sequence. Another example. So, analyze the given sequence for each rule and identify the next three terms. First, 1, 2, 3, 5, 8, 13. So, para makuha na to ang pattern, so 1 plus 1 is equal to 2. 2 plus 1 is equal to 3. 3 plus 2 is equal to 5. So 5 plus 3 is equal to 8. So 8 plus 5 is equal to 13. So 13 plus 8 is equal to 21. So therefore, this is the Fibonacci sequence. So 1, 1, 2, 3, 5, 8, 13. So when we see Fibonacci sequence in mathematics, we can generate patterns by performing several mathematical operations repeatedly. Suppose we choose the number 3 as the first number in pattern. We then choose to add 5 to our first number. So the resulting is 8. So, because sa first 3, then muad ta kuno og 5. So ang resulta is 8. 5 plus 3 is equal to 8. So which is our second number? Repeating this process, we obtain 13, 18, 23, 28 as the succeeding numbers that form our pattern. Let us proceed about mathematics for organization. So we need mathematical tools to help us make sound analysis and better decisions. Example, a particular store can gather data on the shopping habits of its customer and make necessary adjustment to help drive sales. So next is mathematics for prediction. We can use mathematical models Using existing data to generate analysis and interpretations, we can also use them to make predictions. Example, applying the concept of probability, experts can calculate the chance of an event occurring. The weather is a friend. Say example, based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. So, this is the topic for Module 1, and I hope you learned this topic. And thank you and keep safe. That's all.